Alright, so moving on to section 2, we're going to be talking about patterns and linear functions. So we're going to start with some keywords. A dependent variable is a variable that changes in response to the independent variable. So I like to think of it, you depend on someone. So it changes in response to another variable. An independent variable is that variable that causes the change. So, like in our last section, when we had time versus height, time is the independent variable because nothing is causing time to change, whereas the height is the dependent variable because depending on the time determines where the height is. So, dependent, like you are all dependent on your parents to get you places, etc. Independent is when you get to that point where you can drive your own car and you're independent and you can take yourself places because you're able to drive. The other ones, inputs and outputs. So the independent variable, its values are the inputs. So this is our independent values. Whereas outputs would be the dependent values. Alright, so example 1 representing a geometric relationship. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So this is really simple to start by creating a table. I'm going to do a 3-column T-chart. The first column, I didn't want all of that to go away, but I guess it did. The first column is going to be our independent variable, which in this case is going to be the number of rectangles. Number of rectangles. This middle is how we're finding the perimeter. And our last one is our ordered pair. So in our first one, when we have one rectangle, remember perimeter is going to be 2 times the, I'm going to go ahead and go with width first, so the 1 plus 2 times the length, which is going to be 6. And so 2 times 6 is 12, and 2 times 1 is 2, so 12 plus 2 gives us 14. And so here our ordered pair is 1, 14. And then we go to two rectangles. And so I now have a length or a width of 2, because 1 plus 1 is 2. So 2 times 2 plus, now my width or my length, whatever you want to call it, it's going to be the same for all of them. It's going to be 2 times 6. So again, we have 12 plus 4, which will give us 16. And then, so from here, our ordered pair is 2, 16. and we're going to have 3, if it'll let me write. And so then this will be 2 times, again, our width is now, I now have 3 of those little rectangles, so now it's a length of 3, or a width of 3, plus 2 times 6, so we have 12 plus 6, which will give us 18. So then our ordered pair is 3, 18. And then our last one here, when we have 4 rectangles, we're going to take 2 times 4 plus 2 times 6. And 12 plus 8 gives us 20. So our last ordered pair for this, anyway, is 4, 20. So there's our table. We've created an ordered pair. So from here to, so we've created the table. Check. Now we want to create words. And so I'm going to look at this, and I noticed that my width changes to however many rectangles there are. So, excuse me, I didn't realize I was so tired. So we're going to multiply, we're multiplying the number of rectangles in each figure by 2, because we have that many sides. When I write this in words, we're going to multiply number of rectangles by 2. And then we're going to, well, to get the total, you can call it length, width, it doesn't matter. In the book, it's calling it length, so we'll just go with that. Multiply number of rectangles by 2 to get the total length. And then we're going to add, so then add 2 times 6, or 12, because that's what it's going to be for each of them, for the total, yeah, let's write C twice, for the total width, and then, so to get the perimeter. So we just talked about what it was we did. We took 2 times, technically, however many rectangles there are, and then we added the 2 times the 6, and that gave us our perimeters. So now that's words, check. Now we're moving on to an equation, and so the equation, the one thing that's changing is that length. And so when I write perimeter equals, I'm going to write 2 times x plus 12. And then actually we're going to write this as a slope intercept. So we're going to make it y equals 2x plus 12. And so there's our equation. Check. We made a table. We wrote it in words. We've written the equation. And now we graph it. And to graph it, we're just going to use our table. You can change as you graph. We could change this to just go by every other so that we're not having to graph it so small. So like, I'm going to make the 2 actually my 1, and the 4 my 2, and the 6 my 3, etc. as I keep going, just so that, because that's so tiny. And I'm going to do the same thing down here. 1, 2, 3. So at 1, we are at 14. 2, we are at 16. At 3, we make it to 18. It's actually this right up here. We're off the chart. And at 4, we're up here at 20. Oh, I'm so glad that one disappeared. So here's where 36 was. And 1, 2, 40 would be about there. And so we have this line, and we're just going to keep it as dots, no drawing of the line. So, represent this function using the table. So we took the table, we used the perimeter equation in order to find our output. So number of rectangles is our input, our dependent variable, and the perimeter of that is our output, or our dependent variable, because it depends on the number of rectangles. From there, we just described what it was that we were doing in order to find the perimeter. We wrote our equation in y equals form, and then we graphed it. And easily could have graphed down in here either way you want to do, because you're going to be most likely just matching or graphing within MathXL. So, in order to talk about functions and linear functions, I'm going to do that on the next video. So, see you there.